always try that when you have a problem like this, where you cannot see a logical way to do it. Start by trying x equals 0. If that doesn't work, try x equal 1.
Okay.
Okay? And there's a couple of things here. We can see that as x gets bigger, there's no way this works. In other words, x
Right.
equals 1, you already have 9 over here.
Mm.
Okay? If you try negative numbers, in other words, maybe there's more than one solution. It'd be nice to know it if there was. Well, if you try negative values for x, a negative 1 will give you 1/9 plus 1. So there's no way negative numbers are going to get me to 4 either. So this is kind of a tricky problem. It's a little like factoring. It's trial and error. What else you
Okay.
got tonight?
Um, I have a graphing problem,
Okay.
and the equation is f of x equals negative 1/3 to the power of x plus 3 minus 4.
Like that, right?
Correct.
Okay. What's the parent function?
Um,
It's an exponential function. There's the parent function right there.
oh, okay, right, no
Okay.
transformation.
Now, if that's the parent function, what three things are we doing to it?
Reflecting it over the x-axis.
In order, that's correct. So that's the first thing you want to do.
And then, is that a shift left 3, even if it's in the exponent?
Yes. In other words, if we're trying to write this in terms of g of x, well, the first thing we have is minus g of x, right? That's our reflection over the x-axis. But the next thing we have is minus g of x plus 3. Notice that's inside the function. That makes it
Right.
a horizontal transformation. And then finally minus 4. In other words, if you can write the parent function in terms of that, then you know everything that's going on. That's a vertical reflection, that's a horizontal to the left shift, that's a vertical shift down. I'm hearing lots of static. Are you hearing that?
I am, yeah.
What kind of microphone? Are you using a built-in microphone or one that's standalone?
Just the built-in.
Okay. Hopefully it'll go away. If it doesn't, we can try a couple of things. All right, so now let's graph this. I'm going to graph it in 3 steps. What's the original graph look like?
Um, is it the same as a log graph?
Well, it's very similar to something like this. In other words, if I have a standard exponential function like y equal 2 to the x, then they always look like that, right? And that point is always 0, 1.
Okay.
If this base is less than 1, then it doesn't look like this. It basically looks like this. In other words, it acts almost as a vertical or a horizontal reflection. But notice it still has to go through that same point, 0, 1. You know, in other words, if you plug in 0 for x here, you get g of x is 1. So the very first thing to do is to draw the original curve. And this is just something you have to learn. is that if your base is greater than 1, then it's going to go low left to upper right. If your base is between 0 and 1, it's going to go upper left towards the x-axis. Okay. So let's erase that. And now in blue, do the first thing, the reflection.
So it would start in the bottom left quadrant.
Okay, so it's going to be reflected vertically. So what's this point right here?
0, negative 1.
Okay. Now we're going to do the second thing, moving it 3 units to the left. Well, the only way for me to really do that is to just take this one point that I know is on there and move it to there. 3 points to the left, which makes it what?
0,
No?
no,
Left.
negative 3.
Okay, so now that curve looks pretty similar. It's still asymptotic to the x-axis.
Right.
That's not changed yet. Now the third and final thing is to move it down by 4. Well, we still have that point there. I'm going to move it down by 4. Where is it now?
negative 3, negative 5.
And now when we graph it, it's asymptotic to what? What is this line right here?
Y equals negative 4.
Yes, y equals negative 4. And the red line is our final graph. Now, if you wanted to know one other point, we've got one point on there, but perhaps it might be nice to know the y-intercept, that point right there.
Yeah.
How do you find that point?
Set x in the original equation equal to 0.
You got it. So it's minus 1/3 cubed, minus 4, whatever that number is, that's that point on the y-axis.
Okay.
Okay? That's basically the way you're going to do any of these where you're graphing it, graphing these exponential functions. And what makes it exponential is the variables in the exponent. That's all you need. If the variable's in the exponent, it's an exponential function. And this is kind of the parent of all exponential functions. It's some number to the x power. Well, might as well use the number that they gave us, 1/3. All right, what else you got?
F of x equals natural log of x plus 4 plus 2.
Parent function?
Just f of x equals
Actually, we can't call it f of x. We got to call it something else.
okay. So g of x equals natural log of x.
That's why we have to call it something else, because if I call it f of x, then we got f of x being two different things. So
Right.
now let's figure out how to manipulate g of x to match this. What is it? The secret on these transformations is once you figure out the parent function, how can I write the parent function in a manner that's equal to f of x?
You a shift left 4.
Well, this is what I mean.
Oh, okay.
That's what I mean. That's what f of x is. It's g of x plus 4 because it's inside the parentheses, and then the plus 2 is outside the parentheses. Okay? And it's this that tells me what I'm doing. In other words, this tells me I have what? What two things are happening to G of X?
A shift left 4 and a shift up 2.
Okay. Now all we have to do is graph the original. And those always look like, I can draw. Those always look like this, where they always go through that point right there, which is 1, 0. Notice its similarity with exponential functions. Exponential functions always go through the point 0, 1. Logarithmic functions, which are the inverse of exponential functions, always go through the point 1, 0.
Okay.
Now, in green, do the first thing. And here it doesn't matter which order you do it in. The only time order matters is if there's a reflection being done. And then always do your reflections first. And it doesn't, if there are two reflections, they can be reflected in either order. But if you've got reflections combined with horizontal and vertical stuff going on, then you've got to do the reflections first. Okay, so what's the first thing I'm going to do here? If we do this in 2 steps.
Shift the key point left 4.
Okay, what is the coordinates of that?
Negative 3, 0.
Okay. And that curve's going to look like that. And it's also going to have a new vertical asymptote. What's the equation of that vertical asymptote?
X equals negative 4.
Actually, x equals negative 4. Excuse me, yes. Okay, and then in red, we're going to do the other thing, plus 2.
Right.
So this x, this green x becomes what?
Negative 3, comma 2.
And notice that that vertical shift does not change the vertical asymptote. So I'm still going to be coming up through that vertical asymptote. It will change the y-intercept if your teacher ever wants the y-intercept in addition to the key point. Just plug in 0 for x. Well, then that means you got natural log of 4 plus 2 is this value right here. That value is 0, comma, natural log of 4 plus 2. And that is the correct way to write it. Just like that.
All right.
Okay? It looks kind of funny because your y-coordinate is made up of 2 different numbers, but that's the only precise way to write it. I mean, you could look up natural log of 4 in a calculator and put down a decimal approximation of it, but this is actually mathematically the best way to write it.
Okay.
And I don't know that your teacher necessarily wants you to put the y-intercept. In other words, if you don't have to put it on there, then I wouldn't. Deal only with your key points and your asymptotes. It is important to know where that asymptote moves to.
Okay.
Tell you what, since we still got 45 minutes, I want you to try something.
All right.
Log off and log right back on.
Okay.
See if we can fix this audio.
All right.
How is it now?
It's a lot better.
Is it better on your end? It's not on mine.
Oh, yeah, it's better on my end.
Okay. We can get through that if it's better on your end. Because there is a third alternative, and that is to use the phone. In other words, I could just use the speaker part of my speakerphone. But this isn't too bad. All right, what else you got?
Um, so just solving for x,
Mm-hmm.
2 to raise to x cubed equals 1 over 8 raised to negative x.
What is similar about the number 2 and the number 1/8? In other words, I don't have to use logs to solve this. And they don't want you to use logs to solve it. They want you to find a common exponential base for these two numbers, 2 and 1/8. What's another way to write 1/8?
1 over 2 cubed.
Okay, what's another way to write it? That's correct. It is 1 over 2 cubed, but if I want to write that in terms of 2, what is it? That's what a negative exponent means.
Oh.
You know what?
Okay.
I don't know that I can. Let's try me calling you. Do you have a speakerphone that you don't have to hold up to your ear if we use that?
Yes, I do.
Let me just call you. I need you to go up to the audio and switch it to phone call instead of computer audio.
Okay.
I'm going to do the same thing, and then we'll be talking by way of phone.
All right.